Hey everybody. Alright, so we are going to do question 2 and 3 on finding the mass of the meter stick. So question 2, I am not going to follow the blocks, but I'm going to try to, it's kind of how I work through it anyway, so you'll have a good idea, and you can definitely try with your blocks worksheet to get this going. Alright, so we have a 2 meter long metal rod. So I always start with a drawing. So that's 2 meters and it's balanced. So I'll just say that this is the 0 centimeter mark, and this would be the 0 meter mark, and this would be the 2 meter mark. All right, and it's at the 48 centimeter mark is where the pivot is. So that's going to be roughly there. So that's at the 0.48 meter mark. We know that there is a 3 kilogram mass at the 4 centimeter mark, so that's right about there. 3 kg at the 4 centimeter mark. And that's it. Alright, so we have to find the mass of the meter stick. We'll call that mass M. So, right away, I know that there are 3 torques. Torque 1, torque 2, and torque 3. Alright, so somebody's calling my cell phone, but that's okay. So torque 1 is the torque of the mass of the 3 kilograms, so that's R times F. And the R for that is the fulcrum's at 0.48 meters, so this would be I want to make sure it's all in the right units, same units, 0.04 meters. So the R that I want to use is the distance from the 0.48 to the 0.04, the distance between the fulcrum or the pivot point and the mass itself. So that distance is going to be 0.44 of, oops, forget that, that was a mistake, 0.44 meters. All right, so that's my R. My force is just the force from the 3 kilograms, so that's an Fg, and it's going to be my mass times 9.8. Times 9.8. So 0.44 is my radius, my lever arm, times 3 times 9.8 gives me a torque of 12.936, and I'm just going to keep 3 decimals. 12.936 Newton meters. Alright, the second torque, so that's going this way, it's torque 1. The second torque is the torque due to this piece of the meter stick that's on the left side of the fulcrum, torque 2. And it has its own R and its own F. And we've got to figure out what those are. So when you're dealing with just the meter stick, so these two will be just the meter stick. When you're dealing with that, the radius you want to use, the lever arm you want to use, is half the distance of overhanging. The overhang is from the 0 mark to the 0.48 meter mark, so that's going to be 0.48 meters. 0.48 minus 0 is 0.48. But you want to use half of that. So my R in this side is 0.24. So that's my R. Now my mass, force, just going to write it up here, force is m times g. The mass that's causing that force is only part of the mass of the actual meter stick. It is the mass that's overhanging, and of this there are 0.48 meters overhanging out of 2 total meters. So it's going to give me a percentage, so 48 out of 200, or 0.48 out of 2 of the total mass is going to be accounted for. So that's my mass. That's my mass. And then my last thing I have to multiply by is my 9.8. So 0.24 times 0.48 over 2, the percent of the mass that I have on my left side, times 9.8, is going to give me 0.5645, but I said I'd go to 3 decimals, so 0.564. but I have this extra m as my variable, and that would have units of Newton meters. And then torque 3, I'm going to sort of do my squiggle just to show you that torque 3 is that side of my meter stick. And it's, again, R times F. The R I want to use is, again, when it's overhanging, which is the meter stick. My R is half of what's overhanging. Well, what's overhanging is 2 minus 0.48, because you start at the 0.48, it goes all the way to the 2. Whatever that number is, I got to divide by 2. That's my R. This is a very long-handed thing. A lot of you will do this in your head, but just showing you where the actual number comes from. Times my amount of mass. Well, there is 2 minus 0.48 is 1.52. So there's 1.52 meters out of the total 2 meters that are overhanging, which means there's that percentage of the total mass is on the right side. And again, I got to multiply that mass by 9.8 to get the actual force. So these two combined give me the force. So 2 minus 0.48, that's going to be the 1.52. So I got to do 1.52 over 2, which is 0.76. I'm going to do this one out in just that little extra step. 0.76 times 1.52 over 2 is, again, 0.76, but this one is associated with the mass, 0.76 m times 9.8. All of that together, 0.76 times 0.76 times 9.8, is going to give you 5.66. 0. Don't forget that variable m, that's still there, Newton meters. Alright, so we have 3 torques. 2 of them are clockwise. This one's a counterclockwise. This one's a counterclockwise because they're on the left side, and that leaves this one to be the clockwise torque. We got to set those equal to each other. So we have 12.936. There's no m with that. Plus 0.564 m equals 5.660 m. So this side is my counterclockwise torque. This side has to balance and cancel with my clockwise torque, and I want to solve this equation. So the first thing, subtract the 0.564 m from both sides. So you're going to get 12.936 equals 5.66 minus 0.564, 5.096 m. And then last step is to divide by the 5.096. Divide by 5.096 to cancel that side out, and you're going to be left with m equals 12.936 over 5.096, 2.54 kilograms. And you're done. Alright, so again, the key thing on this one is the counterclockwise torques, which are the 2 on the left side, have to balance the clockwise. Just takes a little bit of practice figuring out what is what on each side. Alright, I'm going to try to get through the third problem. So the third problem, we have a 5 meter crossbar pivoting at the 4.6 meter mark. So I always just put my 0 there. This one will be the 5. So this right here is the 4.6 meters. All right. We have 3 kilogram mass. With a hanging weight of 1.4 newtons at the very end. So I have an extra force. So there's a force of 1.4 newtons. All right, and then I'll have to deal with the 2 different sides of the pivot point. So one side and the other side. One side's the x's, one side's the dashes. All right, so my short side is the right side in this one. So I'm going to actually have 2 clockwise torques balancing only one counterclockwise. I have two things acting on the right. So torque 1 equals the torque from the mass. It is 0.4 meters away, R times F. It's 0.4 meters away from the fulcrum, 4.6 and 5. So I just did 5 minus 4.6 to get 0.4. And the force acting is just the 1.4. You're given that. So that torque, 0.4 times 1.4, is 0.56. So torque 1 is 0.56 Newton meters. Okay. Torque 2. Similar idea as last time, where we have to, it's the torque due to the right side, the short side, so it's the torque on this side, right, where I'm highlighting. And the distance, well, you have a 0.4 meter length that's overhanging, so you only use half of that, so that distance is going to be 0.2 meters. The amount of mass that's overhanging, it's 0.4. Decimals don't want to work. 0.4 over the total distance of 5 times the mass, whatever the mass is. So this is the percentage of the mass, of the total mass, and then multiply by 9.8. You get 0.2 times 0.4 over 5 times 9.8, 0.1568 m. 0.1568 m. Newton meters. Again, that m is the mass that you're solving for. That's your variable. Torque 3, R times F, is our radius is 4.6 meters over on this side, our lever arm. Half of that is going to be 2.3. For when you're overhanging, it's just the half the distance that you use. So our R is 2.3. We have 4.6 overhanging out of 5 times m times 9.8. Again, this one we use a 9.8 because we're dealing with the mass on this side. On this first one, we were given it as 1.4 newtons, so that's our force. So we don't use the 9.8 on torque 1. So 2.3 times 4.6 over 5 times 9.8, 20.7368. 20.7368 m Newton meters. All right, again, we want to balance our thing, so it's going to be torque 3 is our counterclockwise, torque 2 is a clockwise, torque 1 is clockwise. So we want to do torque 3 equals torque 2 plus torque 1. Set up our equation. 20.7368 equals our torque 2, don't forget the m, our torque 2, 0.1568 m plus 0.56. Solve, you're going to get 0.56 equals 20.73 minus, I'm skipping one step, all I'm doing is just subtracting the 0.1568 from both sides. So it'll leave 0.56 on one side and 20.58 m on the other side. Final step is solve for m, so do 0.56 divided by 20.58 is going to be 0.027 kilograms. A couple people in class I saw did 20.58 over 0.56, which gave you like 30. The reason you don't want to do that is the m is on the side, so you have to divide by the 20.58 to get rid of it. All right, so there is our answer. Again, I kind of rushed this one, but and didn't obviously show the boxes, but hopefully it helps. So again, torque 3 is this one. Torque 2 is from just the overhanging side on the right side, and torque 1 comes about from our force. All right, hopefully that helps. Make sure you do number 5 on the original worksheet, or check that as a thing. There will be a problem like this, one very similar, nothing more difficult, on the quiz that will happen sometime next week. All right, good job, and have a good night.